Hi, how's it going? It's me, Andre, and I'm going to continue our college algebra prep lesson. And yeah, we're still talking about real numbers, and in this video, we're going to talk about classifying real numbers. And real numbers consist of natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And if you recall from our previous video, that natural numbers they take the number set of 1, 2, 3, dot, 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 to infinity. And also whole numbers take the number set from 0 to 1, 2, 3, dot, 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 to infinity. And integers, they take the number set from negative infinity, dot, 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 that's just messy, dot, 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 to negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, 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 to infinity. So integers, they range from negative infinity to positive infinity. And rational numbers take the form of, for instance, of any fraction like 1/2, 2/3, 3/4, and usually denoted by a over b, where b does not equal 0. So, well, where a is any number and b is any number, but b cannot equal 0. That's rational numbers. But also rational numbers can take the form of a repeating decimal that looks like 5, 9, 5, 9, 5, 9, and does that forever. And also irrational numbers, they're a non-repeating decimal, which could take the form of 0.01001000001, and pretty much continues that sequence for forever. So let's talk about some symbols that you guys might come across in your college algebra course. You guys might come across a notation that looks like this, where you get this little a and this E looking like thing and this capital A. And what this is saying, it's saying that this little a, which represents a number, so this represents some number, is in the member set of A. And A can be irrational numbers, rational numbers, integers, whole numbers, natural numbers. So pretty much is this, they'll say like, well, let's look at an example. Let's say negative 2 is in the member set of integers, which is denoted by the letter J. So, and these questions are generally true and false, so they'll say negative 2 is in the member set of integers, which is denoted by J. And if you recall that negative 2, yeah, it's in the member set of integers. It's right there. So this is true. That's a true statement. And you would either write true or false for that. And let's look at this here. This is also saying that some letter or some number, which is denoted by A, is not in the member set of whatever they're calling out. So let's look at an example of this. We can say that 0 is not in the member set of natural numbers, which is denoted by n. Okay, so, and we know that's true because 0 is not in natural numbers. Natural numbers starts at 1 and works its way up into infinity and goes no further past 1. It starts at 1. So this is a true statement, and you would just say true or false, however your professor or teacher wants you to say that this is a true statement. And next, you might see something that looks like this, where it is a capital letter A with this sideways U with a line underneath, and this capital letter B. So what this is saying, it's saying that this member set A is in this member set B. And that might be a little confusing to you now, but let's look at an example that will kind of clear this up. My arrows are off today. So okay, so let's look at an example where it says this number, or this member set A, is also in this member set B. And we can do that by saying that the natural numbers, and this is just one example, you could do this with almost any one of these. So this example that I'm just coming up with, it's saying that the natural numbers are in the member set of whole numbers. And we could check that answer out and see if that is true by comparing the natural numbers with the whole numbers. So we know that the natural numbers are 1, 2, 3, all the way into infinity, and we know that this member set here is in this member set because these numbers are right here. So this is a true statement. So natural numbers are in or the natural number members are in the whole number members, and that's true because you could almost just slap that in right there. And let's look at this here. You might also see something like this in your class that says this member set A is not in the member set B. And we can look at that by saying that the whole numbers are not in the member set of natural numbers. And we could check the validation on that by comparing them. So if we look at the whole numbers, which is 0, 1, 2, 3, and we know that if we compare those, let's look at that right next to the whole numbers. So if we look at these two, we can say that we can't say that these numbers are in this number set. These member set, which are the whole numbers, are not in this member set of the natural numbers because there's no 0, and we can't substitute, just slap these numbers right in here and it should be a perfect fit. It doesn't work here because there's no 0. And that does validate that the whole number members are not a part of the natural number members. And when you're doing this, you have to look at all the numbers and they all have to fit. So in this case, they all don't fit because we don't have the 0 down here in the natural numbers.